bw'osomeseza omwana wo mu masomero ga Giant Schools omuli kampasi y'Ebombo Kalule n'ey'e Kabalagala toba bweraliikirivu bwonna olw'omusingi okutambuzibwa ebyenjigiriza n'ensoma y'abayizi ey'omulembe. Mu masomero gaffe gano gonna tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuuka ku siniya ey'omukaaga nga tusomesa abaana okuviira ddala ku mutendero gwa kindergarten okutuuka ku kibiina eky'omusanvu. Tulina abasomesa abakugu mu kubangula abaana n'okubateekateeka. Ebibiina abaana mwe basomera eby'omulembe omuli buli kimu ekikwata ku ebyo bye basoma, ebisuula ebyazimbibwa obulungi, ebigazi ate nga biyonjo. Okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga.
Yeah, our dear viewers, good afternoon. Good afternoon. It has been now a week. It has been a week since we last met. But I must say, over the weekend when I was watching news, I saw that some countries are now planning for lockdowns. What does that mean? Most of us had given up. Most people had thought COVID is not there or COVID went. COVID is still there. So, please, I want to urge you again, stick to the soaps again. COVID is real, and if we don't protect ourselves, we might go back into the first lockdown. So let us practice, let us put whatever we have been told in order to protect ourselves from COVID. COVID is real and people are dying. I saw on Saturday that Italy registered the highest cases. The cases it never even registered during the first lockdown. So COVID is real and people are dying. Still on Thursday last week, I think Uganda registered the highest cases of COVID cases that were confirmed dead. So COVID is real. For guys who are day scholars, even when you go back home or when you are in school, please strictly practice the soaps so that we prevent ourselves from this deadly virus. We don't want to go back into the second phase, because it might also happen if we don't take whatever the Ministry of Health is telling us, or whenever we don't follow the guidelines. COVID is real. And what is very funny, for guys who have some bit of science, viral diseases are very complicated. So this being a viral disease, you never know. We might never get any cure or vaccine for it. So let us take whatever we have been told seriously. COVID is real. For guys who are still at home, please put whatever you've been told by the Ministry of Health into consideration. So last week, I had the chance to wind up with iron. I did that roundup by summarizing some of the reactions of iron. And I remember I left you with a question, which question was, what would happen, or what would you observe when zinc granules were added to a solution that contained iron 3 ions? Like they were looking at oxidation reactions of chlorine. Iron 2 can be oxidized to iron 3. But again, we have those substances, or we have those compounds, or we have those elements that can be used to reduce iron 3 to iron 2. And one of them is zinc. When you have zinc granules, when you have zinc granules and you add them to a solution containing iron 3 ions, what do you expect? zinc, 1. Zinc being more reactive than iron, it has that capability of what? Of reducing iron 3 to iron 2. And what happens to zinc? Remember we said in an oxidation reaction, oxidation reduction, that is a redox reaction. Both reduction and oxidation will be taking place. Therefore, if zinc is reducing this to iron 2, for it will be oxidized to what? To zinc ions. Okay, so this is one of the redox reactions we talk about. And when you look at this redox reaction, what has happened to zinc? What has happened to iron? You initially had iron 3, but now you're changing it to iron what? Iron 2. And here we are going to talk of oxidation or reduction in terms of addition or removal of what? Electrons. Therefore, if I simply add 1 electron here, I would have converted iron 3 to iron what? Iron 2. Then when you look at zinc, I have my zinc, but it's giving me what? Iron. So it is giving me zinc ions. Okay? Therefore, what does that mean? That for this to have been converted to zinc ions, it means that there was what? Loss of what? Loss of electrons. So it means that is what happened. Because here I have a net charge of 0, and also here a +2 plus a -2, you'll get 0. Therefore, my equations are balancing. Even here, my equation is balancing. Therefore, what does that mean? Zinc is acting as what? Zinc is acting as a reducing agent by reducing iron 3 to iron 2. But we said a substance which acts as an oxidizing, a reducing agent, for it undergoes what? It undergoes oxidation. That's why zinc has been turned into zinc ions. What do we observe? Because the equation was, state what would be observed. Remember, this is a yellow what? A yellow solution. And remember, we talked of zinc ions in solution. We shall have a pale green solution. Then a person would ask, what about zinc ions? Zinc ions, it's among the cations that are white in color. But when you dissolve them in water, or when you put them in, you react them with an acid, they form colorless what? Solution. Therefore, it means that the colorless solution of zinc ions will be over-masked, or it will be masked, or it will be overshadowed by what? The pale green solution. Therefore, our yellow solution, from what I left you with, our yellow solution turns to a pale green solution. And the second part of that question was, write the equation that took place. That is the equation that takes what? That takes place. Please watch the way you write small n. Small n like small u. They must have this small stick. That's why even when it comes to writing u, copper, if you write copper like that and another student writes copper like this student will be marked correct, for you will be marked wrong. Without the slash, without that stick, it means that your copper, your symbol for small u is what? Is wrong. So here, this is the equation that takes place. Then the other question was, what type of a reaction was undergone? What type of a reaction was undergone? Remember we talked of a displacement reaction, and we said what happens during a displacement reaction? A more reactive element displaces or takes the position of another less reactive element from its solution. That's why zinc, when you look at our reactivity theory, zinc is more reactive than iron. Therefore, it has displaced iron. Okay? It has displaced iron. Okay? It would act as a displacement reaction if we had formed if we had formed so maybe a compound, if this was iron 3 sulfate, if we had formed zinc sulfate. Therefore, what type of a reaction was undergone here? We would not talk of a displacement reaction. We don't talk of a displacement reaction, but this type of a reaction is called a redox reaction. What is a redox reaction? A redox reaction is one where one element or one atom or a given element or a given substance undergoes oxidation, whereas the other undergoes what? Undergoes reduction. We have seen that zinc has undergone oxidation, iron 3 has undergone reduction. Therefore, such a reaction is called a redox reaction. Redox, that is reduction, oxidation occurring in an equation simultaneously. So whenever you have oxidation and reduction occurring at the same time, such a reaction is called a redox reaction. What is very confusing whenever it comes to redox and displacement reactions, most students tend to see any redox reaction as a displacement reaction. It is true. All displacement reactions are redox reactions, but not all redox reactions are displacement reactions. This is one of them. It is a redox reaction, but it's not a displacement reaction. Okay? So all displacement reactions are redox in nature, but not all redox reactions are displacement. Why am I giving this? I said with displacement because most of you who did the work were giving displacement. So you must note it that all displacement reactions are redox, but not all redox reactions are displacement. Therefore, this type of a reaction is a redox reaction. You're having oxidation and reduction occurring at the same time. So we have looked at the observation, we have looked at the equation, and then we have looked at the type of a reaction. And the type of a reaction it is a displacement reaction. So one would ask again, Madam, what is the difference between displacement and then redox? I want to give an example. If I had a reaction like what? Like copper 2 sulfate. Copper 2 sulfate solution, which is blue in color. I also add to it zinc granules. Okay? I also added to it zinc granules. What is a displacement reaction? A displacement reaction is one where a more reactive element that might be more electronegative or more electropositive displaces another element from its solution. And what happens to it? After it has displaced, for it reacts with what has remained. Therefore, zinc being more reactive than copper, it will displace copper. And therefore, what will you form? You will form zinc. You will form zinc sulfate. Okay? After you formed zinc sulfate, what will happen? It means that now copper has been left. Therefore, plus what? Plus copper. Okay? Plus copper. When you try to see this reaction here, indeed it is redox in nature. Why is it redox in nature? Because the zinc has been oxidized to zinc ions, because here we shall have zinc ions. And what has happened to copper? Copper has been, okay, reduced. Copper 2 ions here in copper 2 sulfate have been reduced to what? To copper. Therefore, we shall have, in terms of half equations, we shall have the copper 2 ions reacting, okay? You add 2 electrons and you'll form what? You'll form your copper. What would have happened to zinc? You have your zinc giving us what? Zinc ions. And this can only take place if there was what? If there was oxidation. When you look at such a reaction, it is true it is a displacement reaction, but it is also redox in nature. That's why I said all displacement reactions are redox in nature. They are redox in nature. But it is not true that all redox reactions are displacement reactions. Therefore, this is redox and it is also displacement. The one that we have looked at is a redox what? Reaction. So that is what our question wanted. So let us look at what we are supposed to cover. What we are supposed to cover today. What were we supposed to cover today? We are going to look at extraction of what? Extraction of copper. Extraction of copper. And that is our symbol for copper. When we are looking at the reactivity theory, we said whatever method you're going to use to extract a given metal will depend on its reactivity in the reactivity theory. We said members that are placed at the top of the reactivity theory, how are they extracted? We said they are extracted by electrolysis of their fused salts. Okay? We don't use the aqueous solutions simply because in aqueous solution there is a possibility of giving off bubbles of a colorless gas, and those bubbles of a colorless gas will be for hydrogen. Look here. If we were to look at extraction of sodium and we had used sodium chloride solution, okay, what does that mean? We would have sodium ions and then chloride what? Ions. Therefore, we would also have hydrogen ions and then the hydroxide what? Ions. Okay? What would go to the cathode? We would have sodium ions and hydrogen ions. Okay? But hydrogen ions being lower in the electrochemical theory or in the reactivity theory, they would be preferred, they would be selected for discharge in preference to what? To sodium ions. Therefore, here you'll have bubbles of a colorless what? Gas instead of the sodium metal. That's why when it comes to electrolysis of the salts, we use salts in their fused state, not in their aqueous what? Not in their aqueous state. So we said those metals that are at the top of the reactivity theory, how are they extracted? They are extracted by electrolysis of fused salts. But we said those that are moderately reactive, what happens to them? For them, they are extracted by reduction. Okay? And I told you with reduction, we can use coke, we can use carbon monoxide. But I told you when you look at copper for it is extracted by also reduction, but this time round our reduction is called self-reduction or thermal reduction. You're not using coke, you're not using carbon monoxide. We shall see that. It is also reduction, but the reduction occurs by itself or by the help of heat. That's why some books will say by thermal decomposition of the corresponding sulfides, which sulfides we are going to talk about. Okay? So still with copper, it is with the reduction, what we term as self-reduction or what we are going to term as thermal decomposition. Thermal decomposition of particular sulfides. So that is with copper. So we are going to see how do we extract copper. Before we talk of what happens during extraction of copper, we must know the ores from which copper can be extracted. And what are our ores? The ores include The ORs include, one, we have our chief OR. Our chief OR, and our chief OR is copper. Copper what? Copper pyrites. And what is the chemical formula for copper pyrites? It is copper, then our pyrites, like there we saw. We saw for what? We saw for iron pyrites. Then what are the other ORs that are used? We have copper 1 oxide, and copper 1 oxide, sometimes it is given the other name, which is what? Glance. And what is its chemical formula? It's copper 1 oxide, copper with a valency of 1. Then what do we have? We have, glance, which is, this is copper 1 is what? Copyright. Then we have copper 1 sulfide. Copper 1 sulfide. Which is also known as what? Glance. And this is copper 1, copper with a valency of what? Of 1. That is our copper 1 sulfide. Then we have malachite. Our malachite, which is this is a mixed what? Salt. So that is our malachite. So these are the ores from which copper can be extracted. We have copper pyrites, we have copper 1 oxide, we have copper 1 sulfide, then we have malachite. Okay, therefore our chief ore, this is our chief ore. Like the way you have been doing for iron. For iron, we must know what happens after knowing the ores from which copper can be extracted. Here we are going to meet a new term which is used in extraction of copper. And the new term, whenever metals are going to be extracted, sometimes the impurities are removed. The impurities are removed, and removing of those impurities is what we term as concentration. In concentration, we might have physical concentration, we might also have chemical concentration. What happens during chemical concentration? That's where we do the roasting, that's where we do the smelting, that's where we do the leaching. What happens during physical concentration? That's why we can handy pick, okay? For guys who have done extraction of gold, you can handy pick, you remove those things that do not look like gold. We can have handy picking, we can have magnetic separation, we can also have froth flotation. And froth flotation is what we use in concentrating the ore from which copper is going to be extracted. For guys who are going to continue with chemistry at higher levels, you'll also see froth flotation when it comes to extraction of lead. Okay? So here, what happens? Here in extraction of copper, our first step is going to be froth. Flotation. Froth flotation. For guys who are the senior 4s or the senior 3s, if you've looked at hydrogen peroxide, when you're looking at preparation of oxygen, as hydrogen peroxide is being broken down into oxygen and water, you see those bubbles. Froth, they're like bubbles. Okay, very many bubbles. So what happens during froth flotation is what we are going to apply as our step 1 when it comes to extraction of copper. And in froth flotation, why are we carrying it out? We want to concentrate. We want to remove some of the impurities that are in our chief ore, which chief ore we are going to use as our copper pyrites. What takes place during froth flotation? I told you, froth flotation is one of the different methods under physical concentration. Like the way you'd go and hand pick and remove any impurity. Like the way you would use a magnet to remove magnetic from non-magnetic. In froth flotation, we must have what we term as a frothing agent. A frothing agent. And the commonest use, we shall use pine oil as our frothing agent. But what happens during froth flotation? 1, the ore must be first crushed. Okay? Therefore, after it has been crushed, what happens? The crushed ore, okay, is mixed with what? Is mixed with water. Is mixed with water. And what? And our frothing agent. Okay? So after you've done so, there is a possibility. Remember, in our crushed ore, there were impurities. Remember, we are saying this is one of the physical methods of concentrating, of removing impurities. Therefore, our crushed ore is mixed with water, and then our pine oil, which pine oil is now our frothing agent. What happens now? Air is blown. Air is blown through the mixture. To do what? To agitate or to mix. To agitate is to mix. To agitate or mix the ore and our frothing agent. So after getting your crushed ore, you've mixed it with water and then the frothing agent, what happens? The ore and the frothing agent are going to mix. But all the other impurities, all the impurities in this ore are going to become wet because of the water, and therefore what happens to them? They sink to the bottom. Therefore on top, what will you be having? You'll be having the ore and then our frothing agent, which is our pine oil. And therefore I told you, after you've done so, you need to blow, you need to pass air through that mixture so that the ore mixes very well with our pine oil, which we are using as our frothing agent. And after you've done so, what happens? Water wets the impurities where? Wets the impurities. Wets the impurities where? It wets the impurities in the ore, and therefore what happens to them? They sink to the bottom. Bottom of what? Of a container, or what we are going to term as our concentration what? Tank, where you'd put the mixture. But after the other impurities have gone down, what happens to the ore and the agent? Then the ore and the frothing agent float at the surface. At the surface. Remember now, in your tank or in your container, you would have a mixture up, like there you would have cooking oil and water. Water will be down, and then what will happen? Oil will be on top. That is what will happen in our concentration tank. We shall have the ore and then the oil on top, and then the earthly impurities down. Therefore, what do? You carry out decantation. You decant. You decant. Okay. The mixture is what? Decanted. To get what? To get the frothing agent. And the ore. So when you decant, you're going to pour off the ore plus the oil. Therefore, what happens then? You need now to separate oil from the ore. And what do? We are going to now to apply. We are going to apply anorganic acid. Anorganic acid. Because this is O level, you have not looked at most of these acids. Even if you don't specify the acid you're using, and you simply talk of the anorganic acid. Anorganic acid is then added to break the ore and the frothing agent. And after you've done so, it means that now the oil will be on its own, the ore will be on its own. Therefore, what do you do? Okay, the mixture. Which mixture am I talking of? The mixture I'm talking of is the one that is formed from breaking the ore and then the frothing agent. Is then filtered. Is filtered to obtain the ore, and it is dried. Okay, so we are talking of froth flotation. In froth flotation, we are saying it is one way of removing impurities. And how have we removed the impurities? Remember, we said what happened after we had crushed our ore, and then it was in powdered form. We mixed it with water and then our pine oil. Okay, air was blown through the mixture so that to mix the ore and our pine oil. What happens? The water that you added, it moistened the impurities, and therefore the impurities did what? Sank to the bottom of the concentration tank. And then what happened? The ore and our pine oil had to float on the surface of or at the top of the concentration tank. Therefore, during the process of decanting, what happened? The impurities remained, and you only took off the ore and our pine oil. And then what happened? In order to separate pine oil from the ore, we needed to add an organic acid, which had to break the ore and then our frothing agent. The mixture was then filtered. When we are filtering, what happens? It means that now our ore will come off as the what? The residue. it was filtered, and then it was dried. Therefore, it is that ore now which is dried. It's that now which we are going to roast. Remember, we are saying copper is extracted by thermal decomposition or thermal reduction of a given sulfide, which given sulfide was among the ores that I gave you. I told you the chief ore that is used is copper pyrites. The other ores that are used, we have copper 1 oxide, we have copper 1 sulfide, then we have malachite. So this is the froth flotation. And at your level, at ordinary level, it's only and only among the metals that we use, among all the metals we are going to extract, that is going to use this first method of froth flotation. The other metals at your level, don't use that. But at a higher levels, for guys who are in senior 5, we shall look at other metals that are also extracted, but during that concentration, we also use froth flotation. So at ordinary level, that is at all level, copper is the only metal we are going to talk of when it comes to froth flotation. Okay? Therefore, what happens? Remember, we said froth flotation is a physical method. A physical method of what? A physical method of concentration. But we also have other chemical methods. And after we have carried out the physical one, we are going to carry out the chemical one. Remember now, what do we have? We have our iron pyrites, which is our chief ore. Therefore, after we have carried out froth flotation, the next method is going to be a chemical one, which is going to require to roast. You're going to roast this ore in presence of what? Oxygen. So that you convert it into another ore, and then you also get off. You also get off some of these volatile impurities. Impurities like what? Like this any sulfur that was in the ore. It will be oxidized to sulfur dioxide, and therefore you will get off sulfur in form of sulfur dioxide. Therefore, our next step is going to be roasting. And what happens during roasting? Remember, I told you roasting, it requires heating in presence of what? In presence of oxygen. Okay? Therefore, our concentrated ore, okay, or our ore is heated. Is heated in presence of what? In presence of air, okay, to form iron 2 oxide, comma, copper 1 sulfide, and to evolve sulfur dioxide gas. I told you, whenever you're writing these descriptions, if there is any equation, please back your description with an equation, because sometimes in your writings you might forget out some important aspects, yet in the equations the aspects are brought out very well. Therefore, we shall have what? We shall have our copper pyrites, which is solid, okay? We heat it in oxygen or in air to give us what? To give us iron 2 oxide, which is also solid, okay? Plus what? Plus our copper 1 sulfide, plus our sulfur dioxide gas. This is a solid, this is a solid. We try to balance the equation. Copper, we have copper here, we have 1. This side here we have how many? 2. Therefore, if I multiply with a 2, the copper atoms have become 2. Even this side here I have 2. The sulfur atoms, how many have they become? They have become how many? 4. 2 times 2, they are 4. But this side here I only have 2. Therefore, if I multiply with a 3, the sulfur atoms I will have 3, 4. Even this side here there are 4. Oxygen atoms, how many do I have? I have 6, 7. Okay, but this side, when I multiply this whole compound here with a 2, it also affected what? It also affected iron. Therefore, it means that I will also multiply with a 2. Therefore, I have 2 copper, 2 copper, 2 iron, 2 iron, 8. 4 sulfur atoms. Even this side I have 4. Oxygen atoms, how many have they become? 6 plus 2, they have become 8. Therefore, I multiply with a what? I multiply with a 4. So after carrying out one physical method of removing some of the impurities, we are going to go to the other chemical methods of removing the other volatile impurities. Like sulfur will be oxidized to sulfur dioxide. That's why we are roasting. When we roast, we are heating that ore in presence of oxygen so that we get iron to oxide. We are getting this. This was one of the ores which we termed as hourglass, then also to evolve sulfur dioxide. Therefore, after froth flotation, the next step is going to be roasting. Okay, and after we have roasted, what happens? We are going to carry out smelting. Then a question would be, one would ask, what is smelting? Smelting, for some of these ores, there is a possibility of creating 2 layers, whereby the ore or the metal that you're going to extract will appear at the bottom, okay? And you're going to form another compound which will prevent oxidation of that ore, okay? Like there we looked at molten iron, and on top of molten iron we had molten slag. The same applies here. In smelting, what happens? The iron that you have formed here, the iron oxide that you have formed here, which is also now also an impurity. The iron 2, okay, the iron 2 oxide formed. The iron 2 oxide formed is heated. Okay, in absence of what? In absence of air. Okay, but in presence of what? In presence of silicon dioxide. To form our molten slag. This time round it's not calcium silicate, but it's going to be iron 2 silicate, because this time round we have not decomposed the lime. Okay, we are using this. Okay, we are heating it in a furnace, but in our furnace there is no air, but there is sand. Remember sand, we said sand contains a high percentage of silicon dioxide. Therefore, sometimes they may give you sand and then they tell you to name the chemical compound which is found in sand. That is silicon dioxide. Therefore, iron 2 oxide will react with silicon dioxide to give us what? Iron 2 silicate. To form iron 2 silicate. which is our molten slag. Our equation will be, we have iron 2 plus what? Plus our silicon dioxide, which is a gas, to give us what? To give us our iron 2 silicate. One would ask again, why are we doing so? Remember, we are trying to get rid of impurities. Remember, this is going to be evolved off as what? This is going to be evolved off as what? As a waste gas. Therefore, what are we remaining with? We are remaining with it, but this is an ore from which copper can be extracted. Therefore, this one will also act as an impurity. That's why we are heating it in presence of what? In presence of silicon dioxide, so that will form our molten slag. This time around, it's not calcium silicate, but it is iron 2 silicate. Then what is going to be the last step? The last step is going to be, remember, what are we remaining with from our chief ore? We are remaining with what? Copper 2 sulfide. Therefore, our last step is going to be reduction. And this is where it gets its name, thermodecomposition of a sulfide. Which sulfide are they talking about? They're talking about copper 1 sulfide. This time around, you're going to reduce it from copper 1 to copper. Copper 1 to copper, that is reduction. But this time around, you're not using coke, you're not using carbon monoxide. Okay? You're simply heating. That's why some textbooks will say thermodecomposition. Or other textbooks will say self-reduction. Because copper 1 has been reduced to copper. And the copper that we are going to form is going to be impure. And that impure form of copper is going to be known as blister copper. So the last step is going to be, we'll carry out reduction, whereby our remaining component here, which is copper 1 sulfide, is going to be heated. It's going to be heated. Okay. Copper 1 sulfide is heated. Okay. In presence of what? In presence of air. To form what? To evolve sulfur dioxide, and also to form. Now this is where, for guys who are in senior 5, or for guys who are in senior 6 who have not gotten the chance to go back, but you have looked at copper. Most textbooks of O-level would talk of this going straight to copper plus sulfur dioxide. But at A-level, we talk of another version whereby we shall have to first form copper 1 oxide, which copper 1 oxide will now react with the remaining copper 1 sulfide to form our copper and sulfur dioxide. But this being ordinary level, we shall now form, to form what? To form impure what? Copper, which is also known as what? Blister copper. So we shall have our equation. What will be our equation? Sometimes I've told you in your description, you may not write whatever is needed, but your equation tells it all. Okay? So we have our equation. We shall have our copper 1 sulfide. Okay? Being heated where? Being heated in oxygen. to give us what? To give us copper. Okay, plus what? Plus sulfur dioxide. Okay, we try to balance the equation. And how are we going to balance the equation? We are going to balance the equation there. Like that. I've told you this is very true. This is very true at O level. But at A level, we shall look at another version. We shall look at another version whereby this first reduction, this first heating would be to give us copper 1 oxide. It is the copper 1 oxide which reacts with the remaining copper 1 sulfide so that you form our impure copper and our sulfur dioxide. Therefore, the copper that has been formed here is what? Impure. This is impure copper. And what I've not yet hinted on is that some metals after they have been extracted, they are extracted in an impure form. Therefore, they need to be purified. And one of the methods of purifying them sometimes is by electrolysis. Therefore, the copper that has been extracted here is impure. Therefore, how are we going to make it pure? By purifying it. And how are we going to purify it? By electrolysis. Therefore, the copper obtained is impure and it is purified by electrolysis of copper 2 sulfate solution. Using copper electrodes. The anode and the cathode, both of them are made up of copper. The cathode is made up of pure copper and the anode is made up of impure copper. Therefore, your question will be, we shall start from there. Your question will be, with the aid of equations, describe how impure copper obtained is purified. And it is carrying 7 marks. So we have basically done extraction of copper. We have done extraction of copper. We have looked at the impurities, but remember our main, we have looked at the ores, and please remember the main ore from which copper can be extracted. Thank you so much. Thank you so much. May the dear Lord bless you.
bw'osomeseza omwana wo mu masomero ga Giant Schools omuli kampasi y'ebbombo Kalule n'ey'e Kabalagala toba bweraliikirivu bwonna olw'omusingi okutambuzibwa ebyenjigiriza n'ensoma y'abayizi ey'omulembe. Mu masomero gaffe gano gonna tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuuka ku siniya ey'omukaaga.